All right, welcome. We are talking about Unit 1 Weather, Entry 1 Matter. So the first part of your lesson today is to make sure you click on this link, or it's posted in the folder. Watch that video of the storm and think, what state of matter do I see? And maybe you're thinking, what's a state of matter? Or what is matter? And we'll get there in a second. So take a second, pause, watch this video, then come back. So, states of matter. All matter or all stuff is made out of atoms. Okay, so everything that you can see, feel, touch, breathe, even air, is made out of atoms. And atoms are these small little particles that have a certain combination of protons, neutrons, and electrons. And the differences in those combinations are all the different elements that you see on the periodic table. So here in this image you have a cloud, and in that cloud you have water droplets, and in that water droplet you might have this little red dot thing, and that's an atom. It's an atom, or maybe it's a compound or a molecule. So depending on how things are going, you might get some different answers there. But in general, the smallest thing that you can get to is an atom, and we'll talk what atoms are. So next, let's look at this. All matter is split into two categories. The first of which are pure substances, which is made up of only one type of substance. And pure substances are split into two categories as well. We have elements, as we just said. That's only one type of atom. So if you're to look at the periodic table, the different letters that you see, let's H or N or O, nitrogen, oxygen, carbon, some of these things that you've heard about, those are single elements. They only have one type of atom. So one ratio of one type of protons. The element is made of two parts. You have a nucleus, which has a positive charge, and orbitals, which contain your electrons. Okay, so atoms are made of protons and neutrons and electrons. Second thing you have is compounds, and that's when different atoms of an element combine to form a different substance. It's called a compound. This can be broken apart by a chemical reaction. And there's two types of compounds, ionic and covalent. Don't really get super worried about a lot of these things right now. I just want you to understand that, hey, when I'm looking at that storm, what I'm seeing there is matter. Okay, now is that matter a pure substance or a mixture? Those are some of the questions that we can start to ask. And then I say, is it a pure substance? Is it an element or a compound? What am I seeing? And if you know anything about water, since water is hydrogen and oxygen bonded together, two different elements, that's a compound. And it's actually a covalent compound. But in that cloud, you might have water particles, and in some cases, you might have things like acid rain where you have other compounds there, and that could be a mixture. And that means that mixtures can be separated by a physical means, such as like boiling or filtering. Okay? We have several types of solutions. This is called a homogeneous or evenly mixed mixture. We have many different types. We're not going to get into those a lot. Aqueous we will see in second semester. Heterogeneous mixtures, we have two types called colloids and suspensions. These appear evenly mixed. So solutions are evenly mixed or homogeneous. Colloids appear evenly mixed, or they're heterogeneous though. They are unevenly mixed. And suspensions are made up of really large particles that tend to settle out over time. So think about any time you've seen like orange juice and the pulp sinks to the bottom, that's an evidence of a suspension. Okay? So let's look at this. These two H's, that H represents a hydrogen. So if I look at this right here, do you think that's a pure substance, a mixture, an element, or a compound? So this is actually a pure substance. It's just hydrogen. That's an element. Same thing, just oxygen, just hydrogen. But if I look at this side together, that's a mixture of hydrogen and oxygen. So that'd be a mixture. On this side, I have water and water, H2O. I have two of them. They're exactly the same. That's a compound because they're bonded between two different elements. But since only one type of substance, you guessed it, it's a pure substance. So now if we look at that from a specific thing, we have these things called, and we'll get into this more later, this isn't the primary focus for today, is if I just look at this Fe. If I looked at that, that's iron. I'd find that in one spot in the periodic table, so that's an element. Here I have O2, that's its chemical formula, but it's just oxygens, so that's also an element. And we'll see it written over here Fe2O3, that's a compound because I have iron and oxygen bonded together. That's what that looks like. Okay. So let's look at these diagrams over here. Here I have a black atom and a white atom, and they're bonded together. So that right there is a compound. Okay, that's a compound. All right. So let's start there. That's a compound. Is it a mixture or a pure substance, though? Well, that's a pure substance. I only have one type of thing. But this one's just a pure substance. Okay, so I'm going to abbreviate PS. How do I know? It's two atoms are bonded. I wish that I had a text box that I could go with. And two atoms that are bonded. Two atoms bonded. That's what I'm going to write here. Apologize for writing on the trackpad. It is what it is. Okay. Number 2. Here I have a black atom and a white atom. Each of those represent different elements. So I have two different elements. So this is a mixture of elements. Mixture of elements. Is it heterogeneous or homogeneous? It's kind of hard to tell from there, but I would venture to guess that that is a heterogeneous mixture. Right here I only have one type of atom, so that's an element, and that's a pure substance. I'm going to abbreviate PS. Here I only have black atoms, so that's still an element and still a pure substance because there's only one type of atom. Okay, so all of these represent different types of substances. When you see them spread out like that, that's probably a gas as well. So what I want you to do is pause here, take a second, and just try to match all of these with their description down here. So maybe it's helpful to go through and circle like, okay, there I have 2 blacks and 1 white. Here I have 2 whites and 1 black. 2 blacks and 1 white, so that's the same thing as this one, and that's the same thing as this one right here. Okay, so with those, I have 2 different compounds. So this is going to be letter A. Okay, why don't you try the other 4 for me? Make sure you pause, and then I'm going to have the answers up here in 2 seconds. So pause now, and try them yourself. All right, so focus point for us. Maybe let's just look at box by box. Okay, so right here I have white and black, and all of these are the same. So that's a compound because they're bonded together, but I only have one type. So that's a pure compound. That's letter B. Okay. Letter C, I only have one type of atom, so it's a pure element, and there's only one. It's no mixture, so that's letter C. Here I have 2 elements, meaning they're not bonded, so that would be letter E, where I have my light and blacks together. And mixture of compound and an element, here I have a compound, there I have an element, that would be letter D. Okay, hopefully you got those ones right. Okay, so what I want you to do is look at each of these and think about particle size. Like if I were to go back to this, right here, solutions, these are small, these are medium, and these are large particles. Small, medium, and large particles. So as particles get bigger, they become a different types of substance. So here I have salt water, and so this is salt water. I'm going to abbreviate SW. I'd maybe write out salt water on yours. This is milk, and this is mud. Okay, that's mud. As you move to the right, particle size increases this direction. Okay, so the biggest particles, what happens to mud if you were to let it sit? Well, you get a layer of water on top and some dirt on the bottom. So this is actually called a suspension. It's a type of matter, suspension. Okay. In the middle, I have something that appears evenly mixed or homogeneous, but it's actually not. So milk is a classic example of a colloid. Other examples would be like peanut butter, shaving cream, things of that nature. And then over here I have salt water. This is a solution. The salt is fully dissolved in the water, and that's a general trend of mixtures. Other things would be like air. Air is another example of a solution. It's a mixture of gases. Primarily, when I inhale, I'm breathing in oxygen. When I exhale, I'm breathing out carbon dioxide. But in the middle of that, you also have other gases mixed in there, primarily nitrogen, most common. Solution, colloid, suspension. Apologize for that. Okay, so read each section, highlight, underline the movement. So, and we're going to talk about how to draw that. So solids, are molecules, atoms, or ions that are arranged into a regular pattern called the crystal lattice. Okay, they vibrate in place. That's their motion. They do not move relative to one another, though. We'd say it has a defined shape and a defined volume. So a lot of times you see solids drawn with like these lines around it, and that's like a vibrating particle. But every atom is moving always. Okay, liquids, these are molecules that can flow past each other. So if I want to show the movement of a water particle, I can show arrows like this, where they're able to flow past one another. Okay, and that's a major characteristic of them. They can escape. Some of them, like this one, could escape into the gas phase, called evaporation, right? So they take on the shape of their container, an undefined shape, and they have a definite volume. So definite volume, shape of the container, we call that undefined. Undefined. Gas particles, on the other hand, they're extremely far apart. They travel in straight lines until they collide with something. So if this gas particle kept moving, it would move like this and it would bounce. And it would bounce off. They move faster when it's hotter, so it's directly related to temperature. It's the only thing affected by change in pressure. We'll talk about pressure later. They take on the shape and volume of whatever container they're put into. Undefined shape, undefined volume. So when I look at plasma, let's go back to this lightning storm. When I go back to plasma, what's different about it compared to the other? So in solid, liquid, gas, I only see the molecules, right? But in the plasma, I see that I have ions now, these positive and negative things, and these little green electrons around. And that's where I see my lightning. Note, as you move this direction, heat is added. It gets hotter and hotter and hotter. So plasma has particles that have a positive and negative charge called ions. That's the positive and negative parts here. The little green dots are electrons. So in order for a plasma to form, atoms or molecules of a gas, in this case molecules, have to break apart and give up or take electrons in order to form these positive and negatively charged things called ions. And that's how ionized gases, we know as plasma, are formed. So it can be heat or it can just be energy in general. So even when particles break apart like they do in a plasma, the total amount of matter stays the same, and we call that the law of conservation of matter, or some cases mass. And what that means is that matter can undergo changes, but it cannot be created or destroyed. So when we're moving from solid to liquid to gas or plasma, these are called phase changes. Oh, sorry, I changed it to look like this. So this is what you want to write down. These are called phase changes: solid, liquid, gas. It's like evaporation, condensation, melting, freezing, ionization or deionization. Those are called phase changes. And during a phase change, the substance remains the same substance. Its identity does not change. And that's what's important about the phase change. Imagine like growing up, you're still you, even if you're changing a little bit. That's not a great example. But if I take an ice cube, set it on the counter, and it melts, right? It melts to become a liquid. It's still water in both cases. So now you have your homework. I want you to try to fill in this table. Each of these are going to be used 2 times. And over here, that means I'm going to have 4 heterogeneous and 2 homogeneous answers, because only solutions are homogeneous. So those should be paired up together. After that, you're going to go to this space and we're going to draw a model. This is a new thing for us, so I expect it to be challenging. The little box is saying, what does this solid piece of ice look like in a hailstorm? Or what does this plasma look like? Think about what types of things you saw in this diagram and combine it with the movement that you saw in these diagrams. And can you get a good diagram for that model? If you want, go back, revisit that storm that we saw earlier, and think of the states of matter that you see now. When we look at that, we should now understand that there's different atoms, different molecules, different compounds, different mixtures that are present, and they're always moving, and they're always moving. And we can start to pick some of that stuff out. All right, guys, love you, appreciate you. Have a great day. I'll talk to you soon.